Okay, something I left out of section 3.5 because I want you to finish 3.6 first. So 2 problems I left out of 3.5 I'm going to assign now, and you have 2 problems on them, is what's known as piecewise functions. Piecewise functions are pieces of functions, not the whole graph, just a piece of it. For example, we know how to sketch a graph of all of those. That is, y equal a negative 2. I know how to do that. Y equal 5 plus 3x. 1, 2, 3, 4, 5. That's the y-intercept. Rise 3, run 1. It's a line. And I know how to graph y equal negative x. Rise 1, run 1. The deal is, I don't want the entire graph. On the first, I just went this from x. There's the x-axis. Remember, x is less than negative 3. Not included, you shade to the left. So we're going to go to negative 3 and go on this graph, not include that point, and only take the left end of it. We don't want the whole graph. We want that piece of it. So if I look at the point negative 2, negative 1, negative 2, negative 3, I'm sorry, negative 3, negative 1, negative 2, that point is not included, and I want out of that the line to the left. Excuse me. When I look at this line, again, I look at the x. Remember the x? If I say x is between negative 3 and 0, included, not included, x is between, you shade in between. So I need to go to negative 3 and 0 and just pick that piece of the line. Well, no need to really guess where that is. If x equal negative 3, and you plug that in, negative 3 times 3, that's negative 9. Plus 4 is negative 4. So this line starts at negative 1, negative 2, negative 3, 1, 2, 3, 4. And that is included because... And if I put 0 in, right there, that will be 5. 0, 1, 2, 3, 4, 5. And if I connect that with a straight edge, that's the only line I want. The left endpoint is included, but the right is not. And if I look at the last line, it was this line. If I look at a number line x, which is the x-axis right there, I want x to be greater than 0 or equal. So go to 0 and just look to the right because that's the x-axis. Well, if I put 0 in there, I'll get 0. That's included. And the slope is 1 down, 1 to the right. Connect that with a straight edge. There's the graph. So, it's not those 3, it's pieces of those 3. Piecewise or split functions, meaning I just want slices of those, not the whole line. If I look at number 26, and if I do the same analogy, let me show you really quick. If I say, let's graph those two, a rough sketch will do. That is, if I look at the first, I know that's a line, shifted, y equal 1, and you're going to rise 1, run 1. That's the entire line. Very good. This is a radical, right? And this is going to shift it 3 units down. So that's really 1, 2, 3. And we know a radical look like that. If you're not happy, you could pick points like we did. The inside equals 0, 1. And remember, we want a perfect squared. Put a 0 in there. 0 minus 3 is negative 3. A 1 in there. 1 minus 3 is negative 2. And a 4 in there, that will be square root of 4 is 2 minus 3 is negative 1. 0, negative 3. 1, negative 1, negative 2. And 1, 2, 3, 4, negative 1. So there's the graph. But we want pieces of that. For the first piece, We want x, there's the x-axis, not included, that's this, and less than, doesn't that mean to the left? So if I take this line and throw 0 in, 0, 1, slope is rise 1, run 1, but we only want the piece of that line that's to the left. There it is. You don't want the rest of this line. And was that included? I forgot. That wasn't included. Right? And if I look at the purple, they want x to be greater than or equal to 0. Well, guess what? That works out perfect the way it is. So 1, 2, 3. We said 1, negative 2, 2, 3, 4, negative 1. And there it is. And that's included, right? And there's your homework on 3.5. I'd like you to do number 23 and 25. And of course, those are all not needed. You really don't have to do any of that or any of this. That's just extra for me to explain how this works.